Okay, here we go. We've got a question here about conduction. We know that because we've got insulation here, we've got different temperatures, and we've got thermal contact. As ever, hit pause, try the question, and then press play when you think you'd like to see my attempt to explain the answer. Okay, so we've got solid copper rods of different diameters. Okay, and we're interested in delta Q over delta T if we change the diameter. So the relationship of the thermal energy transfer, the rate of thermal energy transfer to the diameter of the rod itself. So to do this, let's get our equation up. It's the usual one, which is our delta Q over delta T minus kappa times A delta T over delta X. So let's go through these. Our kappa is to do with the material, so we don't need to worry about that at this stage. And delta T, delta X, well in this case it's going to be the change in temperature between Tx and Ty, and then this distance. Now we're going to assume that all of those are held constant, so T, and the length is held constant, so we're really interested in that area. Now the area, excuse me, is going to be the cross-sectional area of the rod, and that goes with pi diameter squared divided by 4. So you notice here we've got a whole bunch of constants here. Okay, in other words, our delta Q over delta T is going to be some constant times d squared. I really should use a small d here, my apologies for that. Okay, but we're looking for a relationship which shows that quadratic relationship, and that's this one here. In other words, the bigger the diameter, the greater the rate of energy transfer. That makes sense to us, and it goes with the d squared, which is shown in, nicely, answer D.